Hello, data science students. I hope you're all doing well, staying happy, healthy, and safe. Well, guess what? It's the end of the semester, almost. So, this is your last full week of classes. You still have a couple days of classes next week, and then we go into finals. But hey, for you guys, you're in luck because you're in a class that doesn't have a final exam, just the cool, awesome neural network final project that I had a Q&A session on today that only half of the amount of people needed to show up to showed up to. Am I upset? Nah. I know you got stuff going on, but it is what it is. So some of you showed up, had some really good questions, and I'm going to go over the questions that you guys asked about today in this video. So I'm going to try something I don't usually do. Matter of fact, first time actually trying this live, and do some picture-in-picture stuff with OBS. And let's see. Ooh, look at that. This is fun. Anyway, so you probably recognize this diagram from your assignment document. And so remember, the whole purpose of your assignment, your final challenge, is to generate training data to train a neural network. And how you're going to do that is you're going to, well, develop test cases, training cases. And you're going to be doing them based on a 10 by 10 image, if you want to call it that, of a die. Like a die, when you say, most people call them dice, but dice is actually plural. They're dies. So, you roll the die and you throw it and it tumbles a bit, and then some series of dots will be facing upward. And that dot pattern is, a 1, 2, 3, 4, 5, or 6. So what you're doing is you're training a neural network to recognize the dot pattern on the die. And it's going to be a 10 by 10 image, like what we're showing here on the screen, that you're going to have to encode as a series of ones and zeros. Zeros being the dark background and 1 being the white face of the dies. And you can see here how this row of zeros corresponds to this row of black pixels, and this row of ones and zeros here correspond to this black pixel followed by some white pixels followed by some black pixels. And you can see the pattern of the six side of the die here in the ones and zeros. Now remember, in the example we went over, we were training our neural network with a single list of inputs, ones and zeros. So what you're going to want to do is turn this shape into a list of just ones and zeros. So you see here, this corresponds to the first row of your image. This part corresponds to the second row of your image, third one to the third row of your image, so on and so forth. Now this is a 10 by 10 picture, so you should in the end have 100 ones and zeros in your list that represents the picture of a side of the die. Now the individual die faces that you're going to have to test for are going to look like this. So we have two sets of test cases I'm going to test you against. Your standard test cases, which are going to be these guys right here, and then your tricky test cases. Your final grade is only going to be determined based on how well you score on the standard test cases. So being able to detect these 6 patterns inside of your die image. The tricky test cases, they're not required, and they only count towards you getting bonus points on the final project. So if you want to get one of those top 3 slots and get some of those bonus points, you're going to have to do both the tricky and the standard test cases. But you're only required to train your neural network to recognize these 6 patterns, but anywhere inside of that 10 by 10 image. So there's a couple different ways to approach this problem. Excuse me. Oh, and here's some examples of the tricky test cases. The tricky test cases are supposed to be hard, so I'm not giving you all of them. I'm just giving you a couple examples here. So like the 6 side at 45 degrees, and all the rotations will be at 45 degree increments, like 45, 135, 90, things like that. So here are some examples of the tricky test cases that I may give you. Not all of them, but some of them. And so, What would be the challenge if I gave you all the tricky test cases to train against? So a few tips that you need to know, uh, and these are the ones that we talked about in our video-to-video uh, session today. So you can generate your test cases any way you wish as long as you're the person who produced them. A lot of you are going to opt to write a program to do this, which is cool. Some of you will opt to open up Excel or open Office spreadsheet or whatever you use these days and draw out your test cases using ones and zeros in cells. If you do that, which is probably the second most common way people do it for this assignment, if you do that, I suggest you turn on conditional formatting so that it shades the cells based on different colors, and it'll help you visualize what your test case actually looks like. There are also some functions in Excel that will help you turn rows and columns into like one string of characters. This isn't a class in Excel, so you can Google it and figure it out. I strongly recommend that you probably write a program to do it. That's going to be the better and easier way for you in the long run. But if you're not comfortable with that, any way you generate that data, as long as you generated the data, I'm going to be happy with it. And for those of you who aren't comfortable with that much with programming or with working in Excel or spreadsheets or that kind of stuff, you can do it on paper with like graph paper and actually draw out your 10 by 10 image and mark off with dark and light cells what your image should look like, and then translate that into ones and zeros in your code. I don't recommend that one because it's going to take forever, but you can hypothetically do it that way. Also, make sure that your training cases are lists inside of lists. So your training cases or your flashcards, as we sort of used the analogy in our previous lecture, is going to be a list of all of the flashcards, all of the training cases. And then inside of that, you'll want to have a sub-list that is a specific training case. So say the image of your one-sided die at one particular location, image of your one-sided die at a different location, or the two-side of the die at a different location, something along those lines. But be sure that your test cases are exactly 100 elements long. If you start getting errors about things being out of bounds, or the size of your inputs not matching the size of your outputs or something along those lines, first, make sure that you've got 100 elements in each of your training cases, exactly 100 elements. The second most common reason for errors like that is that you mismatched the number of training cases or flashcard fronts with training outputs, flashcard backs. So for every case you train it on, you need to have a training output, what you expect to get. So for a one side of a die, you would have a 0.1 in your expected training output. And so make sure that the number of elements in your training list, so in your big list of flashcards or training inputs or whatever you want to call them, make sure that the number of sublists in there exactly matches the number of sublists in your training output or your answers back of the flashcards, whatever analogy you want to use. Make sure they match in size. Now, another common gotcha that we see is that since there's just one output, we're looking for a 0.1, a 0.2, a 0.3, a 0.4, a 0.5, or 0.6, for our 1, 2, 3, 4, 5, 6 sides of our die. Some people forget that you have to provide those inside of a list. Even though it's one element, it needs to be a list of one element. And the reason for that is because the framework we're using can actually train multiple outputs. And so it makes sense to contain those in a single list. But for your final project, you're only wanting one output from your neural network. And that's the number on the side of the die that's facing upward. So make sure that the same number of outputs are in your output list as there are inputs in your input list. So that, using our flashcard analogy, you have the same number of flashcard fronts as you have flashcard backs, inputs and outputs. And again, another common one, people sometimes forget to scale their inputs. This framework we're using trains best on values on the range of from 0 to 1. So training for a 1 side is going to be a 0.1. For the 2 side of the die, it needs to be a 0.2. For the 3 side of the die, 0.3. You see the pattern. So be sure to scale your inputs so that the output, or rather scale your outputs so that what you expect to get will be on the range of 0.1 to 0.6. And also, for most of the training sets you're going to come up with, you're going to want to have hundreds of repetitions. There's only two ways to make your neural network smarter: better training data or more repetitions. And you've got to find the secret sauce, the perfect combination of those two to get a really, really smart neural network. Now keep in mind, you're going to be graded on how smart your neural network is. So check in the assignment document. I've got a breakdown of how to calculate your points that you'll get out of it based on how well your neural network performs. But you don't have to have the perfect neural network to do okay on this assignment. If you want to have a perfect grade, though, you got to have a perfect neural network, at least for the standard test cases. Okay. Yeah, so this is a big one. I see this a lot. We've already mentioned it. Be absolutely certain that your inputs and outputs or your training targets exactly match the format specified in the document. It needs to be on the range, the outputs and targets need to be on the range of 0.1 to 0.6. You need to have exactly 100 elements in your training data, your input, and those all need to be ones and zeros, no 0.5s or 2s or anything like that. Just ones and zeros on the inputs, and 0.1 to 0.6 on your targets or your training outputs. Yeah, and so we talked about this too. A couple of you have probably heard this 4 or 5 times now if you've came to training session or Q&A sessions, watched the video, and came to my office hours. Excel or another spreadsheet with conditional formatting is a nice way to do it by hand if you want to do it that way. You can type it out in text or a CSV file by hand, but really programmatically is probably going to be the best way for you to go about it. And there's a couple common approaches. So if we go back and we look at this, actually look at this one. This is effectively a picture. It's an image. And me, Dr. Jones, VR, computer graphics guy, I think in pictures. So the way that I think about solving this problem is actually treating it like a picture. So, you could hypothetically use like Python image library and make a 10 pixel wide image and move another image of, the die face around to different areas inside of that image. And, you can write a function that would then go through it pixel by pixel and make your list of ones and zeros that then become your training inputs. That's one of the ways I've solved it. Another way I've solved it is, I've tried to actually write it myself using almost every way it's been submitted, so that I understand how to debug it or help you guys debug the issues you get. Another really common way is to treat it like an image, but not use like an image library. You make a multi-dimensional array, so a 2x2, or rather a two-dimensional list. And you propagate it with ones and zeros, and then you move around the image of the die, as ones and zeros inside of that list. And then that's pretty easy to then flatten and convert into a single one-dimensional list for your training input. Another way that's, for me, less intuitive, but some people like it, is to treat it as a text problem. So you've got a string with a bunch of ones and zeros in it, and you generate a string for the default test case for 0, 0 in the image for a die side of 1 or 2 or whatever. And then you just rotate that string. So push a character out one end and pat it to the front. And just keep doing that over and over until you've moved it 5 pixels to one side. Now keep in mind, you can't have a die face where half of it's hanging off one side of the image and half of it's hanging off the other side of the image. Not physically possible, unless you're like playing Portal or something. Or Pac-Man for that matter. That's how the Pac-Man universe works. Doesn't matter. You follow what I'm saying. At least I think you do. You're nodding in cyberspace in the future watching this video, I'm assuming. If not, it's okay to ask questions. No joke. Reach out to me, reach out to Riley, and we'll help you debug these things. But you can treat it as a text problem and just shift characters in a string. For me, that's counterintuitive, but it does work, and I've solved it that way too, just to make sure I could understand how it was being done, and yeah, it works. And if you think in strings, that's great. If there are Perl programmers out there, you probably think in strings. Anyway, so those are the common ways to sort of approach solving the problem programmatically. Let's see, what other things do we talk about in the class? So approaches to data collection. Oh, calculating your final grade. Okay, so here's how you calculate your final grade. You add up all of your quiz points and all of your quiz points, all of your assignment points, and all of your bonus points, and divide that by 1650, 1650. That was the maximum amount of points you could get on your quizzes and your assignments. Bonus points are above and beyond that, so you get extra points for having your bonuses. There was one quiz where I think I accidentally set the grade to be 60 as opposed to 100. If that and on that one, keep in mind that one's actually a 100-point quiz. Add up all your points, divide it by 1060, and that percentage is going to be your final grade. Or 1650, not 1060. 1650. What else about that? You can continue demoing your final project up until the date specified in the document. So do that. Once that date and time hit, though, I turn off the testing website and you cannot submit anymore. The only thing you can do after that is just upload your code to Blackboard. And whatever score you got on the neural network testing site is what you're going to get for your final project. Okay. Yes, the last thing we talked about was NumPy conversion issues. So I wrote this in the challenge document. So when casting your values as float, typically we've used NumPy's float64 or float32 functions. For this assignment, it's going to work out better for you if you use just the float casting function that's built into Python. Not really 100% sure the mechanism for this, because to you the programmer, these two functions appear to do effectively the same thing, but numerically something under the hood is different about them, and your neural network will learn much more quickly and much more effectively if you use the float function to convert your values to a float as opposed to NumPy's built-in float function. So yeah, that'll help you out. Avoid using NumPy's float conversion. Use the float conversion that's just built into Python. Okay, I think that is it. That's definitely all the questions from that was given about the project and grades and everything from our Q&A today. I can't off the top of my head think of anything else to add to that, so I think we're good. If you haven't started, oh my gosh, start like now, because you're already behind. You really need to start. Don't panic. It's okay. You can catch up if you haven't started yet. But definitely, at the very least, copy and paste the sample code from the slides. Be sure you've downloaded the neural network package from the website. And do the AND gate example, the AND and NOR gate examples. Write them up, run it, test it, and if you can get that going, you can make progress towards making this work too. Okay? And like I said, if you have any questions or anything, let me know, let Riley know. We're here to help. Okay, so let me unsquish my video here. Whoop. That's cool. Anyway, I hope you guys are doing well. I hope you're staying happy, staying healthy, staying safe. I hope the semester is ending well for you. And like I said, if you need anything, let me know, let Riley know. Oh, post on Discord. The question section on Discord has been really awesome. I'm glad you guys have opted to help each other out. That's what I want to see. it's good to have a good supportive community for the class, so you guys can help answer each other's common questions, and I want to see that. So keep using Discord. Talk to Riley. Talk to me, and we'll get you straightened out if you have any trouble, or at least try our best to. Up until certain limits, because after all, it's your final project, and you kind of got to do it. Yeah. Well, having said that, I hope you guys are doing well, and I'll see you later. Bye bye.